Hello everyone. Today's topic is about call by reference. So we already in the previous video have explained about the pointers. So pointer is a variable used to store the address of a any variable. So that then generally that complete explanation I have given in the previous video itself. Now today's topic about the call by reference using functions. In function, generally, we already discussed about the call by value. So now, what do you mean by the call by reference? Generally, a pointer variable, if I declare something like a some pointer p comma a variable. Now here I am assigning some here p is equals to address of a. Address of a. Now address of a is a reference. It is generally called as a reference for the memory a address. So ampersand operator for the in case the address of A is something like a 2000 and the 2000 address is stored at the P. Now just I want to just revise the corresponding structure. Now there is a variable and it is an integer type, obviously which occupy the 4 byte of memory. The first base address in case it is a 2000 address. The base address is a 2000. The 2000 address we are storing it a pointer p variable. Now pointer also a integer variable, but it is a pointer type variable, so that it can only store the addresses. The addresses of the a variable is a 2000. Now 2000 is stored here. This is the real address for the 2000. By this way, this variable always pointing to the memory A. Now this is a memory. The address is a 2000, which can able to operate with A, which can able to operate with A, and also operate with P. Operate with the two variables are now two names are operating on same memory. So the name of this memory is a actual memory. On this memory, we are if the value of memory is a 5. If you perform something like a plus plus, a plus plus, then what is the value will become? The value will become a 6. Followed by, also I want to done something like a pointer p plus plus. Then what is going to be happen? The value increment at same memory, same memory. Okay. Now p, the effect, whatever you apply operation on this variable, pointer variable also reflected this memory. The A itself is a name or reference name for this memory. So directly that increment, arithmetic operation, all are reflect on this memory. So this is the general pointer concept. Now we are implementing this pointer in a function call or function calling parameters. Let me start with a simple program, swapping program. Here I want to explain a very simple program, swapping program. So how to do the swapping? Before go to the swapping concept, first let us call. I'm creating some void. Call this is a calling function. I'm declaring some two variables. A comma b and followed by now scan it. I'm entering the values for a comma b. A first ID comma address of A and address of B comma address of B. So like that, now enter the value or read the value by using scan. Followed by, actually I want to perform the swapping between A comma B. A comma B are local variable to main function. Now here I am calling swap function. Swap. Okay, the swap of two values, A comma B. Generally, your entered values are 5 comma 6. Example, A value is 5 and B value is a 6. Now we want to see that 6 comma 5 like that. Now I can also pass 5 comma 6. Whenever you pass the values from the variable, or else if I pass something like a name of the variable, A comma 6 like that. These kind of parameters are called as the actual parameters. The calling of function is calling the function by using values. Here 6 is a value. A is a variable and which contains some value. So call by value. This is called as a call by value. Call by calling to a swap function by passing the values, direct values, a value, 6 values. So call by value. This nature is called as a call by value. But in what is our concept? Call by reference. Same concept we can use, but call by reference. Now you pass the parameter not directly values. You have to pass the parameters with addresses. We know that how to represent the address of a variable, address of A, comma, address of B. Now this notation will provide the address of A, base address of A and base address of A. A base nothing but first byte address will pass into the pass as a parameter. They are not values. Address of A will provide address of the variable. Now example to here. If the according to this one, two variables are created now. So I'm drawing the one another diagram for this program. There are two variables are there. First A and second one is a B. They are 4 byte of memory. 4 byte of memory for each because they are integer type. The first byte address is a 2000. I am writing for only first byte address. Second byte address will become a 2001. So we no need to mention the second byte address, third byte address like that. The first byte address is a 2000 for A. Similarly, the first byte address for B is equal to something like a 3000. Let us consider it is a 3000 address. Second byte address will become a 3001, 3002, 3003 like that. Okay. Now the name of this memory is a. Now name of this memory is a B. Like that, we already prepared the two variables and with addresses. Now we are passing addresses. What are the parameter values? The first parameter value will become a 2000 will pass. Second parameter value will become a 3000 will pass. Actually, the values are what are the values? Here we have a 5 value. Here we have a 6 values. Now we are not passing the value. We are passing parameter. Parameters as a reference. So this kind of scenario is called as a call by reference. Calling to a swap function by passing parameters are references or addresses. So this concept is called as a call by reference. Call by reference. Now followed by, I just want to close the main function. Okay. So after you this function, we know that control will transfer to the swap definition part. Somewhere here I'm writing the swap definition before the main function. Okay. So swap function will first start go from the main function. A declaration completed, memory created, values also assigned, followed by the next statement is a directly swap function. So swap definition, call the swap definition. Here I'm writing the swap. The return type is a void, then followed by I just want to execute function. Now, what are the values are passing? Addresses are passing. What they are addresses. They are not values. Address of A, address of B. So address only will be passed. As the address, we should take a formal parameters. The formal parameters should not be a normal variable. They should be pointer variables. They should pointer variables because the only the pointer variables can only store the address of any variable. To store the address, we should use the pointer variable. So that formal parameters are must be a pointer variable. Now pointer P1 for a first parameter, pointer P2 for second parameter. So like that, we should mm, declare parameters. That parameters are must and should be a pointer variables. If I declare a normal variable like a x comma y, x comma y, now x is become a normal variable. Normal variables are not assigned with the address. They cannot assign it the address. They consider address as a value. If you assign something 2000, yes, we can able to store in x, but the x will consider that is a value, not a address. But we want to operate everything with the address so that you should declare as a pointer variable. The pointer variables are created. Okay. So then what happened here? Now, after creating these two pointer variables, we want to perform a swapping. For the swapping, we should use on top variable temp. Now, temp is a local variable for swapping function. The next, what is my statement? Next statement will become want to swap. So let me write the statements how we are swapping. Well-known statements, temp is equals to pointer P1, next followed by P1 is equals to pointer P1 equals to pointer P2 semicolon. Okay. Pointer P2 is equals to now pointer P2 is equals to 10. This is a swapping. I will explain the code properly. How this code is going to be run. A function call is created, but what are the parameters are passed? Addresses are passed. Now the first statement. Now what is the first statement? The first statement could be the first pointer P1. Which parameter will be received? Address of A. That is become a address of A. But it is a initialization. It is a pointer initialization. Remember, this is a initialization. So normally we are practicing the statements in such a way. If I declare something like a int p, int star p, now something like a variable we are declaring. Now point p is equals to address of A. So this is the notation generally we had a practice. This is nothing but declaration in a one statement, and after that we are assigning address from another statement, another line. So this is the thing. This is the thing we practiced in a previous video. But what is this kind of statement? This is like an initialization. You are declaring pointer there. You are declaring. So here only here I have declared, and there only we are passing some value, reference value, address of A. Now this is, seems like in this format. It is declaring there and assigning address to the P1 at the same line only. So this is generally initialized. So now a pointer variable has been created, pointer variable P1. Now P1 store the address of A, address of A. So address of A is equal to 2000, 2000 code here. Now this P1 always pointing to the which memory? P1 pointing to the memory of A. Memory of A. Now, whatever the things you are applying on P1 will reflect at PA directly. So now this is a common memory. This memory address is a 2000. Now, two variables are operating this memory. One is A itself. A itself will operate on this memory. And now P1 also will start operating. P1 also operating. So single memory now control with names. One is a pointer variable, one is a variable name A. Now next variable is A. Next what happened here? Second address is the address of B. Now address of B transferred to the P2. So now P2 has been created. P2 has been created. P2 also a normal variable. So it is a pointer variable. Pointer variable P2. Pointer variable P2. Now P2 store the address of B. So now it is pointing to this location. Now it is pointing to this location. Okay, so now these two variables are stored the addresses of A comma and P2 address of B. Now what we are doing? So there is a one more third variable. So third variable we need to perform the swapping operation. So here I have taken a temp variable. A temp variable I have taken temp variable. Now what happened? Temp is equals to P1. Actually, we are transferring the P1 value. What do you mean by the star P or pointer P or indirection operator P? So now normal P provide the address of the A. Normal P1 provide the address of A, which means it is the only P1 store. What is the value at P1? Address of A, address of A. So 2000 value. But if you are using the indirection operator with P1 name, now which provide the value at this address. Value at this address. What is the value at this address? 5. Now which provide the value at this address. So by using the redirection operator only, you will get a value at that corresponding address. Now similarly, now we are operating with pointer P1. You have a value at this location, not address. Value at this location. At this address, we have some value. So that is a value 5. That value now transfer to the temp value. That value transfer to temp value. So now from where the P1 is collecting the value, it is collecting from A only, not from P1. So this value will transfer to the temp. The magic, actually A comma B variables are local to main function. These variables are now pointed with our swap variable, local variable, swap local pointer variables. They are pointing. P1 comma P2 are local to swap function. A comma B are local to main function. But here what happened? This local variable P1 comma P2 pointing to the A comma B. Now, whenever you apply any changes from P1 that reflect from A comma B. Now, what happened here? A value transferred to temp variable. A value transferred to temp variable. Now, but we are operating with P1. We are operating with P1. So now what happened here? 5 will be transferred. high value transfer. See, and also drawing the line from A to temp, not from P1 to temp. Actually, P1 stored the address value. It is address only, na? So from based on this address, actually control travel to here. Now from there, the value will be accessed and which transfer to temp variable. So like that, the communication built from pointer variable to A to temp. Now, P2 value transferred to A. Now P2, nothing but this one. Now 3000 is not transferring. 3000 is address. Pointer P means at this address, what is the value? So we are first to reach the B1. Now from this B1 value transferred to next to pointer P1. Pointer P1 nothing but it is address where it is representing. Pointer P nothing but again A. So now exchanging between A comma B. But actually, our code writing we have given with pointer variable P1 comma P2. But what happened here? So instead of it is actually a real exchange between happened from A comma B. Pointers are just pointing their location now. Nowhere we am doing A is tempo, A is equals to B, B is equals to temp. That statements I have not given. We just given the pointers. No point, but pointers are physically exchanging, creating a transfer from A comma B only. Now tempo value transferred to tempo value. Now A value. What happened here? B value transferred to A. Now what is the B value is become? Now it is become 6. Now it is become 6 value. A value will become 6. A value becomes 6. Okay. Now what happened? Temp transfer to P2. What is the temp value? Temp value 5. Temp value for transfer the 5 over to here. 5 over to here. What is the new value at temp? Temp value is become a 5 and A value becomes 6. So now exchange completed. This is 6. These values become 5. Exchange, they interchange. But a real interchange happened between memories of A, B, and temp. But we controlled everything with a P1 comma P2. No need to return anything from swap function. Already the swapping completed between A comma B. But don't write anywhere the code like A. I don't write anywhere code like A, some temp is equal to A. Okay, now A is equal to B. These statements I have not given. Now B is equal to 10. These statements I have not given anywhere. We are operating the same kind of scenario with the pointer variables, but a real thing happened in this format. While you are executing these pointers in the memory, this kind of exchanges are happened. These kind of exchanges. Okay, na? So no need to return anything. Already swap executed now. But already reflected comma b variable. Now the process completed, the swapping process completed. You directly come to the state, come to here and print a comma b. Now printf percentile d comma percentile d comma percentile d a comma b. You will get result the swap result of 5 comma. You will get the output as A is equals to 6, comma B is equals to 5. You will get this result. Your input values are 5, comma 6. But after swapping function executed, your outputs are become 6, comma 5. So this is the magic from this kind of magic we can see from pointer variables only. The pointers are directly operating on memory of the assigned variable. So now on this memory, you just remember this pointer, how the pointers are operating. A single memory is there, the reference name is A. On this memory, we are assigning authority by using a one more variable, pointer variable. Now, if you apply any changes on P1, which reflected this memory only. If you apply any changes on A, also which reflect on same memory. So this is the scenario. This is about the call by reference. Let's practice the one more problem. So this is a swapping problem. Let's now practice the one more problem like um, also like sum of n numbers, sum of n numbers we can practice. Very simple program, sum of n numbers also. We want to see that sum of n numbers. And after sum, we want to print the result. We want to print the result. But how we had a practice, A normal function call, how we are operating in a call by reference concept. Let us discuss now. So generally I'm expecting the sum of uh, n number of sum I'm expecting. So x carry the n number of values 1, 2, 3, 4. What is your how many values you want to transfer using for loop? We should control with x. And finally, we are expecting some kind of return value y. Let us consider. Now I'm passing. Let me first write the code. Then scanf. Go to the scanf. We have and the n values. How many values you want to make sum? So that I am writing scanf. First, let's enter for any how many number of values you want to do some percent only, comma. That I want to store it x. Okay, na x. Now we want to see the final result from y. Final result from y. So I just want to call it compute compute function. Then first parameter I'm passing as a address of x. Something address you have entered a value is something like a 10. Now 10 number 10 sum of 10 natural number, first 10 natural numbers like that. And I want to pass for the value of result at y. Okay. I'm calling the function. Let's go write the code for compute function now here. Now compute is calling. It is also void. Void, no need to return anything. Compute. The first parameter is used for in pointer n, which access the value of how many values you want to make it from we are storing here. The final sum I want to store it this variable, some variable, some variable done. Now I'm using for loop for before for I want to declare I. Now for loop for I is equal to 1, I less than pointer n. We have a pointer n value already that was defined from main itself. It may be a 10, 12. If it is 12, sum of 12 natural number 1 plus 2 plus 3 plus like that up to 12. Okay. And now I plus plus I plus plus. What it is going to be for every time that pointer sum is equals to pointer sum plus I value. Pointer sum plus I. No need to return the result of sum. No need to return the result of sum, which directly apply the changes set variable y or output variable is the pointer y. Sorry, print final variable because y address coded sum. So final result of sum reflect on y like that. Like that, the final result will be receive at y. So that I am printing what I will do y. I'll explain with proper structure. First, let's start from main function. How many variables are there here? X variable, y variable. Two variables are there. Okay. The base address. These are the base addresses. Base address for x value, base address for y value. Okay. Now this is name of variable x and this name of the variable is y. Example, you have entered x is equal to 10. Now we are expecting the sum of 10 natural numbers. The final value we want to store it y. So that two pointers are created. The first pointer is a n pointer. Second pointer is a sum pointer. N is pointing to x value. So only we will get how many number of sum you want to perform. We can access from x and the pointer variable n. Okay. So now this 10 will assign to n, which seems like a. This seems like a. What is the format? Sum int pointer n is equal to address of by that way, which will get pointer n value will become a 10. So like that 10 value will get at the n. Now it is pointing to this location. We want to more focus on the next variable sum. Now sum is a pointer variable. The pointer variable shows the address of what is the address it has been shown? 3000 y value. So the variable name is a sum. Okay. Now it is pointing to the location 1. We don't know what is the initial value. So, but here I am also initialize the value for I, it is 0. Value for I, it is 0 and semicolon. Okay. Initial value of y is equals to 0. Initial value of y is equals to 0. Oh, now what happened? Whenever passing these two parameters, at the ampersand x and ampersand y, x pointed with n, y pointed with some variable. Now the assignment completed. Now here I am also writing for pointer sum. Pointer sum is equals to address of y, semicolon. Okay. And I is equal to 1 initially. I less than pointer n. What is the pointer n value? Pointer n nothing but it means that indirection operator n, which access the value as a 10. 10 value will be accessed. Now by that way it is the less than 10. Okay, and in the first iteration, what happened? Control will for every true condition, control will enter into the block. What is the block value we have? Sum is equal to sum plus I. What is the initial sum? In your first iteration, uh, what is the sum value? That sum is equal to 0 plus 1. The second iteration, what happened? What is the sum updated value? 0 plus 1, how much? 1. Now 1 will be assigned to sum, but sum nothing but it is a pointer variable. That result again, where the result will be stored? Result again stored by variable only. Sum is just a pointer variable. It is also it is a pointer variable operate on same memory. This is a memory. For this memory, there is a y variable, and also we are controlling with some variable. On this memory, two variables are controlling. One is y variable, one more is a sum variable. Now you have applied some changes by using the sum variable, pointer variable, but the reflection is happen at y itself. Now sum is equals to sum plus I. Pointer sum is equals to pointer plus sum plus I. It means that in your first iteration, sum value 0, y 0, so sum value also 0. 0 plus I is equal to 1. 0 plus 1, 1. So one will be stored here first initially. The second iteration already some value last modified value 1. So next time it is become a 1 plus I already plus na I already plus. So I incremented. I value become 2. So next time it is become a 1 plus 2. 1 plus 2 it is become 3. This become 3. Next updated value 3. Now actually we in this statement we can see the updation at some variable, but sum is not a store to value. It is used to store the address. The actual reflection is created in y itself. Next third iteration, what happened? Third iteration already the sum value 3. Now 3 plus this time I plus. I is incremented to 3. So now 3 plus 3. Like that we updated with the 6 value. Next updated value 6. Okay. So finally, the last value up to 10 values we are adding now. The after, last value is becoming 55. Last value after you adding all the values, the updated value will become a 55. Now 55 is stored in the y itself. But nowhere we are using the y in this corresponding function. But only y itself it is affecting. This memory only affecting with the reference of some variable. Okay. So whenever you come after executing this statement, control come to the calling point. Now, what is the next statement? Next statement is the printing one. We are even not reading anything from the compute function, even though already the result is updated at y. Already result updated. So by using pointer concept dynamically, simultaneously, the result is updated at the pointer normal variable. Simultaneously, how you are operating from this pointer at the same time, simultaneously, the reflection also happening in the corresponding variable. Like that, we can see without even written the value, the updated value, we can print from y. Okay, so this is about call by one more program by using call by reference. In the next class, I will explain new concept on say on pointers.